Okay, so we're going to continue with some of this Algebra 2 stuff that we're doing. And we're going to talk about some advanced factoring. I don't know, the word advanced might be misleading. It's more of just, hey, factoring that you haven't really seen before yet. So we're going to talk about sums of cubes, differences of cubes, and then some extensions of factoring by grouping. So first of all, perfect cubes, they're like perfect squares, but it's like 1 cubed. So 1's a perfect cube. 2 cubed, which is 8. 8's a perfect cube. 3 cubed is 27. 27's a perfect cube. 4 cubed is 64. So 64 is a perfect cube. 5 cubed is 125. So 125 is a perfect cube. You can keep playing that game if you want to get a whole bunch more perfect cubes. Let me show you how to do some factoring of perfect cubes. So the first one that we're going to factor is x cubed plus 8. So first of all, notice that x cubed is a perfect cube, 8 is a perfect cube. So right away, my initial inkling on this is that when I factor it, I know it's going to factor to like x plus 2 times something. Because I know that that something, whatever's in there, I know there's going to be an x plus 2 factor just because of an x cubed in the 8. So now if I think about doing a little bit of multiplication here, I know that if I multiply x times something, I have to get x cubed. So there's going to be an x squared there. I know that if I multiply 2 times something, I'm going to get 8. So there should be a 4 there, a positive 4. The question is, what goes in the middle? So that's what comes up next, is how do I figure out what goes there? So, well, let's play a little bit more with this distributive property. I know that if I multiply 2 times x squared, that's going to give me a positive 2x squared. But there is no x squared term in x cubed plus 8. So whatever I multiply x by has to cancel out that negative 2x squared. So if I multiply x times negative 2x, I'm going to get a negative 2x squared term to cancel my positive 2x squared. So then the factoring of x cubed plus 8, just to write a little bit neater, is going to be x plus 2 times x squared minus 2x plus 4. So let's try that again with x cubed plus 64. So again, I know it's probably going to be an x plus 4 because the cube root of 64 is 4. And I know I'm going to have an x squared because I need an x cubed. And I know that I'm going to need a positive 16 because 16 times 4 is 64. But then again, what's going to go in that area in the middle? So if I do some multiplying, and again, let's take a look at it a little differently here. Instead of doing the x squared, take a look at this. If I multiply those together, I get a positive 16x. So what I multiply here has to give me a negative 16x to cancel it out. What number is going in the box? A negative 4x. So that might motivate you to think of this a little bit. So I'm thinking if I'm going to factor a sum of cubes, and it's like x cubed plus some number a that I cube. So again, I recognize that 8 was a perfect cube, so 8 is like 2 cubed. 64 is a perfect cube, so that's going to be like 4 cubed. I can rewrite this then as x plus the a value, and then I'm going to multiply that. Let's see, I have an x squared. Now, I'm looking inside, I have like a negative 2x. I have a negative 4x, so it's going to be a negative a times x. And then I'm going to always end up with a squared. So this is my factoring of my sum of cubes. Let's keep moving. So the difference of cubes, we're going to go the same way with it, and it's going to be really, really, really similar. Check it out. So first of all, 27 is 3 cubed. So yeah, there's going to be an x minus 3 in there. And you're right, there's going to be an x squared term. Now, in order to make a negative 27, that's going to be my negative 3 times a positive 9. There's my negative 27. Now, if I multiply x times the middle term here, I need to also get, now I don't want to do that yet. I'm sorry, I went a little bit too far ahead. Alrighty, thanks for bearing with me. So now when I do my multiplication, if I do like x times 9, I get a positive 9x. So negative 3 times something has to cancel that out. So it's got to be a negative 9x. So maybe you're thinking positive 3x. That's going to work for me. So take a look at that pattern. See about the next one, x cubed minus 125. Alrighty, so if you said that it went x minus 5, and then you need your x squared, you need your positive 25, and let's see if I multiply these two terms, there's my positive 25x, so that has to be a negative 25x. So I'm going to make that a negative 5x. So that's going to motivate you to do something generally. So again, if you have something like x cubed minus some number a that you're cubing, let's set it up. X minus a times x squared. Oops, I'm sorry, that's a plus in there, right? Yeah. Plus, not 5, plus ax. This is why Mr. Baker is so good at Algebra 2. Plus a squared. There we go. All right, so now we're going to move on a little bit more. Now we're going to get into some other factoring by grouping. So you might remember last time when we did factoring by grouping that we kind of set it up for us already by splitting it down the middle. Well, we're going to do the same thing here. We're going to split it down the middle, and we're going to do 2 GCFs. So the GCF of the first two terms is x squared, and that's going to leave behind an x plus 2. Now, here's a little secret. If you're going to factor by grouping, this term has to be the same as the first one. So I like to do it this way. I like to write that other x plus 2, and then I say to myself, okay, what number do I put on the outside? What do I multiply by x to get negative 9x? What do I multiply by 2 to get negative 18? If you said negative 9, you were right. And then that's going to give you an x squared minus 9, and it's going to give you an x plus 2. But wait, there's more. Notice that x squared minus 9 is a perfect square. So we can factor x squared minus 9 into x plus 3 times x minus 3. And then I'll bring down my x plus 2. And that answer should make sense to you, because if it's an x cubed, there should be 3 x's in it. And there are. So that's pretty good. Do you want to tackle the second one? Here we go. I'm going to split it down the middle. Take out my GCF. Let's see, I have another GCF of an x squared, and that's going to be x minus 6. So again, I'm going to cheat a little bit. I know I need an x minus 6 there. So what do I multiply this x by to get me negative 25x? How about negative 25? And negative 25 times negative 6 is positive 150. So if I keep rocking, I'm going to get x squared minus 25, and I'm going to get x minus 6. And then when I multiply those, or again, noticing the x squared minus 25, gives me an x plus 5 and an x minus 5. And then I bring down my x minus 6. Boy, this factor by grouping is fun. I wish I could take Algebra 2 next year. So our last one has a whole bunch of terms here. But again, we can just keep factoring by grouping. Our last one, we grouped together 2 pairs of terms. So now let's group together 3 pairs of terms and see what it brings us to. What I mean by that is I'm going to factor those 2, then the 2 in the middle, and then the 2 at the end. And they are going to have a common factor, so let's see what we can do. When I factor the first one, I'm going to get x squared as a GCF, and that's going to leave behind x squared minus 16. If I take a look at the second one, it looks like there's a GCF of 5x, so it's a positive 5x. And guess what? There's my x squared minus 16 again. How about that? And one last one then. I think I know what you're thinking. There's going to be another x squared minus 16 there. And in order to get the term above it, I need a positive 6. So yeah, one of my factors is x squared minus 16. The other factor, though, is x squared plus 5x plus 6. Pretty cool. Let's factor each of these now. The one on the left is your difference of squares, so we get x plus 4 times x minus 4. The next one's a trinomial, so if I think about numbers that multiply to 6 and combine to give me a positive 5, how about a positive 3 and a positive 2? So these 4 binomials, when you multiply it all together, can give you that big old term there. Holy cow.